Hi, I'm Katsumi. Today, I'm excited to talk to you about how to add AI assistant functionality to existing applications using the Accessibility API. It has become normal to use AI assistant for programming tasks. This video is a demonstration of GitHub Copilot on VS Code. AI returns very accurate results for programming tasks such as explaining functions and refactoring. Human programmers can save a lot of time by taking advantage of AI. Have you ever wanted to be able to use AI assistant not only in specific IDE, but anywhere? For example, your favorite text editor or a web browser? In this session, I will present the core technologies to realize such requests. So let's get started. I'm going to explain how to integrate AI assistant functionality into existing applications. In this session, I will show 4 sample applications. These will illustrate how to use the Accessibility API. They are all available as sample code in my GitHub repository. This video demonstrates the first application. Select text and press the keyboard shortcut to ask the AI about the selected text. The application shown in TextEdit app, which is pre-installed on the Mac. Of course, it does not have a plugin mechanism. As in the Xcode example shown earlier, I let AI refactor the selected code. One of the core technologies required to achieve such functionality is to retrieve text displayed by other applications. Another is monitoring of global keys and mouse events to trigger this functionality at arbitrary timing, such as when a specific shortcut is pressed. The Accessibility API makes the impossible possible. It to be used in testing and automation software allows to access and manipulate UI elements of the system and other applications. It is very powerful, so to use the Accessibility API, you need to fulfill the prerequisites. The Accessibility API can read information from other applications. To prevent abuse, application must be explicitly granted permission by the end user. Also, the sandbox must be disabled. In summary, to use the Accessibility API, 2 steps are required in advance: disabling the sandbox and granting permission to the application by the end user. To disable the sandbox, remove the App Sandbox section by pressing the trash icon button on the Signing and Capabilities tab in Xcode. To grant permission for the Accessibility API, add the application for which you want to grant applications to Accessibility under Privacy and Security in System Settings. Then turn on the toggle switch. It is not easy for users to add application to privacy and security, which is located deep in system settings. The Accessibility API provides function to help with that. The AX is process trusted with option function does 2 things. It adds the application to the list of accessibility settings in the privacy and security settings. It also displays a dialog message prompting the user to grant the permission, and allows the user to open the settings directly from the Open System Settings button. The Open System Settings button opens the system settings as shown. All that's left is the user simply turn on the toggle switch. Let's take a look at the basic usage of the Accessibility API. You can get the value of any UI element using the AX UI element copy attribute value function. The first argument is the UI element containing the value you want to retrieve. The type of object that can be passed is AX UI element. AX UI element is a proxy object for the actual UI element. The second argument is a key string, that is the name of the value that you want to retrieve. The last argument is the return value. Since the Accessibility API is written in the C language, the return value is passed as an argument with a pointer. The return value indicates the kind of error. Let's look at a real-world example. To retrieve the selected text, pass the KAX selected text attribute constant as the key. In this code, the AX UI element passed as the first argument is the UI element that currently has focus. Let me explain where this object came from. AX UI element is a tree structure similar to an actual UI element. To traverse an AX UI element, the root AX UI element is required. In this case, I created the system-wide AX UI element as a root object because I want to work with the various applications, not just a specific application. The system-wide AX UI element is created with the AX UI element create a system-wide function. It provides an access point to system-wide accessibility information. In other words, AX UI element objects created using this function are not limited to the individual applications or processes, but allow references to any UI element of macOS. So, the focused AX UI element can be retrieved from the system-wide AX UI element. The constant that indicates the focused UI element is KAX focused UI element attribute. This is the basic way to traverse the AX UI element tree structure. Check the return value to see if the value was retrieved. A return value other than success indicates failure for various reasons. For example, the sandbox is still enabled or an attempt to retrieve a value that is not contained, and so on. Next, monitor shortcut key events so that they can be triggered at any time. A prompt input window appears with the shortcut key. There are several ways to monitor events globally. First, I introduce add global monitor for events, which is a class method of NS event. It can receive keystrokes and mouse events generated by other applications. I want to React keyboard shortcut, monitor the key down event, then check the modifier flags and key code properties to evaluate the shortcut key combination. As another way to set global shortcut keys, install event handler and register event hotkey functions. This is Carbon API. Although outdated, this API has the characteristic that it does not require accessibility permissions and not require disabling sandbox. The code is too long to include in the slide, but there is a sample code in my GitHub repository. Please see the details. Another API is event tap. This is an API that allows you to literally tap events. The big difference is this API can stop the propagation of events or modify events if necessary. This is what the word tap indicates. See the sample code for more details. So far, the selected text has been retrieved by pressing the short key. The remaining work is just to show a window to enter the prompts and request to the OpenAI Web API. I won't explain about how to code the UI and the Web API because they are out of scope this session. Please see the sample code for details. If a web view is used, the text cannot be retrieved this way. For example, web browsers or mail application. Instead, use AX selected text marker range to get the selection, and AX string for text marker range to get the text of the selection. Now, you can get the text from any application that uses WebView. I mean, the procedure to retrieve values using the Accessibility API may fail depending on the target UI element. Therefore, it is recommended to try multiple methods and fall back on failure. The code example from earlier, the function below appears the first time. This is AX UI element copy parameterized attribute value. It is similar to AX UI element copy attribute value, but takes an additional argument. You can get more detailed value with the name of the key and an additional argument. The argument passed here is the selection range retrieved from the function above. That is, it retrieves the text of the currently selected range. These keys are not defined as constants. How to know these undocumented keys? There's an API to search the names of such keys that are not defined as constant. The AX UI element copy attributes names function returns a list of names of values that can be retrieved from an AX UI element. This is one of the sample applications in this session, which inspects the UI elements at the mouse cursor position. It shows the value of the UI element at the cursor position and it tree structure to the window. You can learn how to get the different types of values that AX element, UI element has, and how to convert the values as necessary with reading this sample code source code. The next sample application is seamless integration between text editors and AI assistants. Monitor text input to trigger functions. When a specific text /assist is typed, it triggers the function. Then, the results are directly reflected to the editor. Use a notification mechanism to achieve this functionality. Here is an example code for receiving notifications. First, create an observer that receives notifications. Observers are created for each specific application, cannot receive system-wide notification. Add the notification you want to receive to the observer. In this example, observed KAX selected text change notification to monitor text input and changing cursor position. Notifications with the perfect content are almost never provided. Therefore, notifications are used only for triggers, and the content is retrieved using the Accessibility API. That is how you can create a fine-grained UI. To modify the text, check if the AX UI element is editable. The function AX UI element is attribute settable returns whether or not the AX UI element can be modified. If it is editable, the content can be modified using the AX UI element set attribute value function. That's it. We can now use the inline AI assistant like VS Code in TextEdit app. Thank you. The last example is an application that translates lines from comic books. The Accessibility API does not provide a way to directly retrieve non-text content, such as images. In this case, it uses the Screen Capture API to retrieve the content as an image. The Accessibility API is used to retrieve the coordinates of UI elements. The API for capturing screenshot is provided by Screen Capture Kit framework, and screenshot can be captured by calling the Screenshot Manager's Capture Image class method. Another method used until just recently is the CG window list create image function. It has been deprecated in favor of Screen Capture Kit. The sample code also shows how to use this function. See the code for details. Screen recording permission is required to use the Screenshot API. The CG pre-flight screen capture access function checks the screen recording permission. CG request screen capture access displays the system dialog to ask for the permission. Use OCR to retrieve text from images. To convert lines from Japanese comic books into text, it is tough to beat vertical writing. Thanks to the Vision Kit framework, vertical text can be recognized with amazing accuracy. The image is analyzed in Image Analyzer of Vision Kit. The recognized text can be retrieved from the transcript property. Then, the AI translates the retrieved text. It is difficult to get the order of the lines correct automatically. It may be possible to solve this problem by creating a UI that allows selection per panel, for example. Accessibility API are very powerful, but to achieve the desired behavior, creativity is important, such as combining different frameworks or innovating the UI. All the applications I have shown you today are still proof of concept. I hope that this talk will inspire some of you to develop even more practical and brilliant applications. So far, I have explained the basic usage of the Accessibility API, notifications, screenshots, and how to inspect the attribute of an AXUI element using sample applications. Sample code can be accessed from my GitHub repository. I hope you will try it out for yourself. I hope you found the Accessibility APIs very powerful and that you can create useful software with your own creativity. That's it. Thanks for listening.